spend a little time with an introduction. My name is Giacomelli, and I am the director of the Controlled Environment Agriculture Center. And this is the 17th annual Greenhouse Crop Production and Engineering Design Short Course. In the name, production, crop production, and design for good operations. The two have to go together, and I hope you'll get at that out of this discussion during this week. I want to welcome you all here. I appreciate you being here. I think we have 100 plus people attending this year. We'll be here for 3 days, and then we're a day at the workshops on campus, and that's a time when we really enjoy showing you around our facilities and where some of this good work comes from, and for some of our classes where we teach the future growers and developers and teachers of controlled environment agriculture. I don't see Austin. Normally at this point he would be giving some advices about how things were going, but I think I see a pretty good group of people, and here he is, Austin Smith. I'd like to, everybody knows Austin. If there are problems that you have or concerns you have, speak with Austin. He can get things done, or of course talk to any of us with the speaker's name tags, and we'd be able to help as well. Austin, anything? Crowd now.
Enjoy yourself. Thanks for coming. If you need anything, let me know. If you got feedback, please bring it forward to me. Good stuff, bad stuff, it's all useful. We will use it. So, other than that, enjoy.
All right. Here we go. What you just did was give me shelter and talk about a storm, create shelter and provide environmental control, or else we just fade away. There we go. I'll speak about I will speak about structures, including start off, very brief introduction. Dave, how are we doing? Okay. Each of engineering design. To take this, you are entering a unique group of people that have preceded you, and I hope will follow on afterwards from around the world. So we thank you, and we will enjoy the opportunity to participate with you this week. If you've seen Bull Durham, there's one part that really, the movie, that really gets me going. Game. You throw the ball, you hit the ball, you catch the ball, and then the coach asks you, you got it. And I could say, this is a simple plant. You plant, you fertilize the plant, you hopefully harvest the plant. And that's what we're here today and this week, is to get that point across, that the basis for particularly engineering design is to try to promote an effective growth of the plant. And so, structures and glazing. I'll give a brief introduction on that. Single layer polyethylene greenhouse, as you see here. We'll see that in the future as well. But example of probably the lowest cost glazing, and many times the most effective that you can utilize in greenhouse dominated by plastic, although of course is glass. Layers. How are we doing? What if I use this? The greenhouse coverings are dominated by plastic with properties that include ultraviolet inhibitors, infrared radiation absorbers, anti-condensants, and different radiation properties. But basically, you have three choices. Glass, lasting many, many years. Rigid plastic panels, lasting 15 or 20 years. Or plastic flexible films, lasting depending on where you are and its particular quality. And then you have a second choice, single layer or double layer. Single layer has the lowest cost, the largest amount of sunlight entering into the greenhouse. And a double layer will cut your heating costs by to 40%, depending on your location. So, and then of course, reduce light transmission on the order of 10% as well. So these are the choices that you have based on these categories of type and configuration of the plastic or the glass. The beauty of glass, it looks like it's not even there. We hope that the plants are seeing the clarity that we see, because what's important is the light's energy that comes through the glazing to get to the plant to make it grow. It's not important what your eyes perceive as the best glazing. So there are ways to determine that. Talk to the people that manufacture. They'll give you the information that you can confirm the quality and the intensity of the light. Low-cost single-layer polyethylene in a ground-to-ground hoop house, or even this is not quite up to. This is only a 10 or 12 foot wide. With a single layer of plastic, and it's growing some bedding plants in it, grown on the floor, just to keep the environment, wind, rain, and add a little bit of heat during the day. You'll notice there's no ventilation and there's no heating in this system. It really is somewhat of a holding and growing. The high tunnel technology is now very popular. Certainly around the U.S. and had been around the world for many years. Sure, ground to ground, no electric power necessarily. Cooling is done by rolling up those side walls that you see on either side. Bring them each day as you enter the evening to try to hold in the heat that's collected during the day. In this case, crops are grown directly in the soil. Double-walled polycarbonate, a rigid plastic material, coated with acrylic to improve light quality and durability in the 15 to 20 years. You'll see some of this material we have at the university when on Thursday. Here's shown only on the sidewall, but obviously, of course, it can be on the roof as well. With that in mind, I'd like to move on to heating systems and then a little bit about cooling. Basically, there's two options. There's hot air and there's hot water. Hot air systems will tend to be less expensive than hot water systems, but there can be improved uniformity of heating in your greenhouse with hot water systems. And the water can be also not just to blow the hot air through the greenhouse, but it also can be under the bench to warm the root zone of the plant, as well as on the floor, the entire floor of the greenhouse being heating system. What are your requirements? The surface area of the greenhouse, these affect how much heat you need to put into your greenhouse. The size of the greenhouse, not the floor area, the surface covering area of the greenhouse is what you have to consider. The insulation value of that glazing, the radiation properties of that glazing, how tight the glazing covers the greenhouse to reduce infiltration. Infiltration is really unwanted air exchange between inside and outside. It's not ventilation, it's unwanted ventilation if you think about it. And the air temperature difference that you want to maintain inside the greenhouse compared to outside the greenhouse. Example, unit heater, gas-fired unit, and I'll bring to your attention that this is mounted overhead in our greenhouse. As you can see this, there's an exhaust flue, so we're near the byproducts of combustion are exhausted out of the greenhouse, never to be put into the greenhouse, and there's a fresh air intake located on the wall as well. Whenever the heater operates, fresh air louvers open up, and it's proportional. The size of those louvers, that opening, is proportional to the size of your heater. And we can have these informations available for you if you have that specific question. So we need fresh air for combustion. We need an exhaust location for the combustion gases that leave the greenhouse. And then off to the this direction here, the hot air blows out from the heater because of a fan located behind it. We use natural gas because we have natural gas. It is the most cost-effective fuel for heating a greenhouse at the moment. That may change, but at the moment. The alternative is propane, certainly, in bottles that are containers that are brought in. And still, I guess, fuel oil as well. There's a picture of the heater located overhead above our tomato crop in the far end of our greenhouse on the end wall. Another example in a greenhouse that you'll see at the research center is the ventilation fan with the plastic tube overhead. And essentially the fan blows the air through the greenhouse from the outside or from this heater that when it's operating, this fan here blows it down the tube. This is the outside screened inlet. When we want to ventilate, we would open up this screened inlet and blow cool air down that tube. We wanted to heat, we would turn on the heater located back here. The hot air would be sucked in by the fan through here and then distributed across the roof area of the greenhouse down the entire length in a means to get uniform distribution. Here is an image looking about a forced hot air heater. Looking from above, you see the inlet, the heater, and then the tube perforations to distribute the hot air. And if you look at it from the side, the door might be at this location. There is the overhead heater and the fan distribution unit. This can also then be in recirculating mode where you shut off the heater and you shut the shutter so no outside air can come in, and have the distribution fan turn on just to circulate the air inside the greenhouse. If we can go to a first stage ventilation mode where the heater again is off, but now the fan operates with that outdoor, that shutter wall open, bringing in fresh outside air to distribute from the greenhouse. And the purpose of this is to reduce temperature, of course, but it's also to reduce the amount of moisture in the air of the greenhouse. The hope is that you have cooler, drier outside air into exchange, and you need a opening at the far end if this is going to allow the exhaust gases to, the moist, warm air gases to leave. We can also do a dehumidification mode, which is having the heater operating at the same time as the ventilation. And short term, I hope, because essentially that becomes expensive. You're bringing in cool, dry outside air, preheating it with the heater, and then distributing it throughout the greenhouse. The hot water pipe generally can be a perimeter 2-inch pipe, for example, that is mounted along the edge of the greenhouse so that you can have the complete interior for growing your crop. And it's connected to now a hot water boiler, not a hot air provider. That can be distributed throughout the greenhouse. You'll see tomato systems. If that can be put underneath benches, that's an opportunity, or along rows of tomatoes, as you'll see in our facilities. Here's an example of underbench heating. Thin pipe, aluminum pipe underneath this tabletop here to provide the warmth and allow the heat to rise up through the bench and warm the crop. This is the hot water pipes distributed along the length of the row, also called a transport system, because essentially these pipes travel the length of the greenhouse, providing warmth, but also could be a track, like a cart track for device that can move the greenhouse and for harvest or prunings and even elevating the people these tall tomato plants. And finally, the concept of root zone or floor heat, where the hot boil is lower temperature water in the 100 to 120 degree Fahrenheit range, very small diameter pipe, plastic buried in the floor of the greenhouse. So the entire floor becomes a warm radiating surface to provide heat, to raise the temperature in the greenhouse. These will depend on the crop you're growing. You saw the tomatoes with the rows of pipe. That can work out well. This might work better for bedding plants or potted plants that are grown on the floor. We have grown tomatoes in this way as well. There's the example of concrete floor heating system growing poinsettias directly on the floor of the greenhouse with a framework of pipe for transportable tables that can be located for crops that are grown at another time of the year when you're not needing poinsettias, but growing other crops, bedding plants and flowering potted plants, for example. Horizontal airflow fans, small fans that are distributed throughout the greenhouse, not to ventilate, not really to cool, just to move the air. And it's important to move the air so that the temperature will be more improved, the distribution of the temperature. Air movement around the leaf increases the growth of the plant because of carbon dioxide and oxygen exchange at the leaf, as well as moisture exchange of the leaf. So, therefore, here's an example of overhead looking at that 2-bay greenhouse where you have a circular pattern where the heater is at one end and these fans can create motion around each bay of the greenhouse. Ventilation and cooling. Our challenge here is to overcome the greenhouse effect. The beauty of the greenhouse effect is it can provide warmth for the greenhouse and the crops growing in the cool season of the year. The challenge of the greenhouse effect is that it can provide heat and warmth at the time of the years you don't need it or there's way too much. So you need to be able to ventilate, and that is exchange the air from inside to outside the greenhouse, as well as cool the air. And we speak much about evaporative cooling, which actually is reducing the air temperature lower than what the air temperature is outside, and if you were just ventilating. We'll look at that. And then shading is something that can be done to reduce the solar radiation coming into the greenhouse, to reduce the heat derived from that solar radiation, but of course also reducing the amount of light that's available for the plant to grow. So that has to be cared. For ventilation, here's a very large greenhouse with a whole series of fans that are mounted on one end wall. The benefits of the fan, the air, when you turn on the motor, there's a positive displacement of the air. The air moves out of the greenhouse immediately. There's a quick response. You have the ability with all those fans to control them in a sequence so that you don't put full capacity of all the fans operating simultaneously in the wintertime. Save that for the summer. In the cooler season, you start with one, say 10%, of all your fans operating, and if the air temperature keeps rising, then you increase that to 30, 50. But at some point, your control system, with an X number of fans running, should be able to reduce the air temperature in the greenhouse.
They turned something on right around there. You're good.
How's that? Is that better? Are we doing there? Okay. All right. I didn't like the red one anyway. The yellow one is much better. Thank you, David. Okay, and we can combine the fans with other systems being the evaporative cooling system that we'll see shortly. We know how to size the fans. The people in the exhibitor area who sell these systems know how to size the fan on terms of what you need. I'm just saying that fundamentally, in this case, you look at your floor area, displacement of the greenhouse floor area, multiplied by 8 or 10 CFM cubic feet per minute per square foot, and you have the amount of fan capacity you estimate that you need. So a 24-foot wide by 100-foot long greenhouse, 2,400 feet, multiplied by 8 or 10, you get between 20,000 and 24,000 cubic feet per minute of fan capacity. This has been developed. Could you put more? Yes. But this has been developed to give you a cost-effective amount of air movement for a greenhouse based on the capacity of the size of that greenhouse and the capacity of the fan. If we look at again a top view of a 24-foot wide by 100-foot long greenhouse, control sensor in the middle, about at eye level or at plant canopy level if you wish, fans located on one end, inlet openings at the other end, and air movement from one side to the other. Distances at 100 feet are a good number in that sense, because as you bring in the cool air, you're bringing this into a solar collector, right? The greenhouse effect. So the air is being warmed as it's traveling towards the fans. So you'll see a differential temperature from one end to the other, which depending on your crops, 100 feet should be sufficient. Others have gone longer, and it depends whether you can tolerate that increase. The inlet openings are also sizable, that we know how to put not too many, not too big, but sufficient size so that the fan can move that air through the greenhouse with sufficient capacity. The louvered shutters are basically square openings at the far end of the greenhouse opposite the fan. It's a point source of air coming through, but it mixes as it goes through and is discharged by the fan. The end wall could also have a motorized window, and I'll show you a picture of that, which then if the window is the entire width of the end of the greenhouse, as opposed to having one or two square shutters, then you have a more uniform line source of fresh air coming into the greenhouse. This also, too, has to be sized properly, that you have the hinged window that opens up X number of inches to get the area that the fan needs to draw the air through that greenhouse. Not too small to reduce and stifle the fan, but not too large so that the air, particularly if it's cold, the air can enter the window and just fall to the floor, as opposed to coming in with a jet of air and mixing with the air, the warm air in the greenhouse, and tempering that warm air. Again, it's about uniformity of cooling. Here's the example of an end wall with a hinged motorized window, and you can see the small, tiny opening, just a couple of inches at this point, probably a stage 1 cooling, and as you would turn on more fans, this window would open further and further, typically with a maximum opening of about 1 foot. But again, it has to be designed based on the number of fans, the size of your greenhouse, and then the width of the greenhouse as well. And we can do that. The location of the inlet, the location of the fans. The fans essentially provide a negative pressure on the house. So it's like sucking on a straw. The fans are sucking the air out of the greenhouse. So it doesn't really matter what height they're located at on the far wall, as long as they're opposite the inlet. So they start sucking on the greenhouse and the air comes in through the inlet. Therefore, it's the location of the inlet that's more important, particularly in height relative to your plants. The fans, you might choose a height that's out of the way, less chance of injury to people. You still put a screen on it, but if you have them higher, that's fine. The distances that I mentioned before, 100 feet for a freestanding greenhouse, that example of the 24 by 100 makes sense. If you go to multi-span greenhouses, I'll show you how you can go much, much more than 100 feet, maybe double or more. Again, the temperature rise occurs from inlet to fan. And an image to show you that if you have airflow for a shutter, the air can just move in. It's fully open or fully closed. There's no choice. If you have airflow coming through an inlet window with a variable opening, can give you much more jet of air coming through there to get better mixing and cooling in the greenhouse, particularly important during the winter months when the air temperature is cold. Again, from the top view, the louvered shutters showing more of a point source and even a bit of a dead air space in the middle between the two, where it might be a little bit warmer, whereas on the line source of the inlet window, it has to be much more uniform across the entire width of the greenhouse. Evaporative cooling. In this case, we're using water and the evaporation of that water to cool the outside air, to cool the air that comes into the greenhouse to be less than the temperature of the air outside. It also simultaneously humidifies the air because we're evaporating water. You have the potential to modify leaf temperature in this way, for good or for bad. You have to think about that. And of course, it can be used for propagation with our misting systems. How does it work? Water evaporates. For water to evaporate, it takes energy. When it consumes the energy in the vicinity of the evaporation, then the temperature has to fall. That's all it is. The air is cooled and it's humidified. The evaporation rate depends on how much moisture is already in the air that you're trying to evaporatively cool. So if you bring in dry outside air, then that can be cooled significantly. If, example, classic here in Arizona or in semi-desert regions where the air humidity may be single digits or 10%, we can get a 35-degree Fahrenheit temperature drop going through our evaporative cooling pad. 35, 105 outside, 70 coming through the pad on the inside. Of course, then that air has to move along the length of the greenhouse, and it will mix and be warmed to get some temperature you want in the hot climate of the day. If you have higher moistures, 60 to 70% relative humidity, then I see a lot of people shaking their heads. Yes, that's more typical. Then you won't get 35 degrees, but you can get 10 to 12 degrees Fahrenheit with a properly operating system. Temperature drop 10 degrees. As the moisture in the air goes higher and you get into this 75, 80, 90%, then it's 3 or 4 degrees at most that you're going to achieve. Therefore, it becomes less interesting, but still can be usable. Oh, one very important thing. To have continued evaporation and cooling, you have to keep ventilating. You cannot just spray the air with, when you see our fog systems, and turn off the fans. It will cool, but then it will reach a saturation. The air will be filled with moisture, and there will be no more evaporation, and therefore less cooling. And you end up with high temperature and high humidity. Not good, not good. So then we have to have the fans running to bring in fresh, more outside air to evaporatively cool that. 3 systems, pad and fan. misting and fogging. Components, the pad and fan. Essentially, let's look through here. Here we are at a trade show, and you see the pad system, the brown in the middle. That is on the end wall and allows the air to be sucked through it by the fans. And then there is a water system at the bottom, a storage and a pump, which pumps water to the top of the pad. It trickles down through the pad, and the moist pad meets the cool or dry air anyway from outside, and that's where it's mixed and the evaporative cooling occurs. Here is the system mounted on the end wall of one of the greenhouses that you would be able to see, except now we have covered with a screen for insects control, but basically it's what we use in our 30 by 100 foot greenhouse. The size of this is also dependent on the size of the greenhouse. Again, the provider of the system can do that design for you, but if there is an interest to know how, we would be glad to talk to you about that. Here's an example of a very large greenhouse that has a separation between two zones. As we walk down this walkway, there is a 100-foot greenhouse zone to the left and to the right in this picture. And what you're seeing here is the wet pad. The air that would, on the right, would move through the right 100-foot greenhouse, and the pad on the left would bring air into an evaporatively cool air that goes into the left 100-foot greenhouse. The fresh air comes from above, so there's an opening with a screened inlet to keep insects out, that when the fans turn on, the air is drawn down through into this walk area, which is a transport aisle and a whatever could be used. It certainly makes access to all the greenhouse zones, because you see it goes and goes. Relatively large, several hundred acre facility. Different concept, different size, of course. But the fresh air then moves through the pads and goes towards the fans at the far end of the greenhouse. Here we are standing outside, and that's that walk space in the middle. You see the roof openings on the top, and you see the beginning of each greenhouse going right and to left. A very interesting way of getting a multi-bay structure to be larger than 100 foot to make the best use, in this case 200 feet, to make the best use of the pad and fan system. Low pressure is used many times for propagation, but basically it's 40 psi, a relatively high volume of water, 4 gallons a minute, and you need an overhead pipe network to have the misters spray down on your plants if you will allow your plants to get wet. That's part of the cooling aspect. Not always a good solution. Larger water droplets, less energy to pump it, evaporation by contact, you control by intermittently spraying. And you need good water quality because your plants will turn whitish with the salts that will evaporate, so you have to be careful about that if you have high salty water. Fog system is similar, except that it's much more higher pressure, 1,000 psi or greater, up to 2,000 psi, where there's a lot less water coming from each nozzle. Again, a distributed nozzle system overhead and controlled, in this case, in combination with the fans, because now you're evaporatively cooling with fog, and you need to distribute that fresh air into the greenhouse after the evaporative cooling has saturated the air that's already in the greenhouse. Tiny droplets, instant evaporation, and here's where the fog system can function for those areas where your outside air is normally a higher humidity. The 10 to 12 degrees Fahrenheit was data that I've measured under the 60 and 70% relative humidities when I was on the East Coast in my studies. The 35 and 30 degrees is here under the very, very low conditions for even the pad and fan, but especially for the fog cooling. And these are the numbers. I did have it highlighted For humid climate, 3 to 12 at times, 10 to 35 in our climate, cooling with the fog system. It's a major investment, but it can provide that cooling where the pad system may fail because of the size of your greenhouse, or may not fail, may not work as well as it should, or that you need to get more cooling than is possible with the pad. Let's look at a greenhouse system that I can show a fog operating. Here we are, one fog line down the middle of the greenhouse at the truss, not all the way at the peak of the roof. You see the roof is open because it's a naturally ventilated greenhouse. 15 seconds into operation, and then 45 seconds into operation. So you see, you don't run it long, you cycle it. You let it run, you fill maybe not even this much with fog, have your controller monitoring it, and then shut it down. Let's speak just very little about natural ventilated greenhouses. Natural ventilated greenhouses work primarily where the wind blows. When the wind doesn't blow, the air doesn't move very much. However, there is the chimney effect, which says that if the air in the greenhouse is warmer than the outside air, and you open a vent in the roof, the hot air goes out, the cooler air comes in. That's a very good physical phenomenon. The problem biologically is that if the air temperature in the greenhouse, the air temperature in the greenhouse can never be cooler than outside temperature. So when do you need natural ventilation the most? In the summer, when it's already hot outside. Works quite well in the winter period of time without fans, but in the summer that becomes a challenge because you can never cool below outside temperature. In fact, it'll always be a little bit warmer inside than outside temperature. You want your outlet to be at the peak of the roof, and we prefer a continuous vent along the entire roof. This is less to show you this design. This is only one opening at the top. In fact, what we prefer is to have two openings, one facing the right and one facing the left. In this case, the whole roof opens, so that can't be. But that would be preferred to have two of vents, one facing opposite each other. All right. This is a gutter-connected greenhouse, and the truss connects between the far gutter and the post where we're standing here with the picture. It allows you to expand to very, very large facilities and to have relatively tall facilities. The taller the greenhouse in general, the better for environmental control. This house is 13 feet from the ground to the gutter and another 3 feet to the peak of the roof. Greenhouses now are being built 16, 18, 20 feet to the gutter to try to improve the climate control that you can get. Okay, this is the continuous opening on the roof. It's a rack and pinion drive, and then this has sidewalls that can roll up because it's, in this case, being used as a single bay greenhouse. Obviously, when you go to a multi-bay greenhouse, then you would have no sidewall openings. You would just, all the air would be coming in through the roof. Just important, for natural ventilated greenhouse, the taller it is, the better, so that you create that chimney. Chimneys work well if they're tall, and that's because it's warmer at the bottom, cooler at the top, and you get a very strong draft. So if you have an 8-foot greenhouse, the natural ventilation doesn't work so well. Of course it works, but it means that the hot temperature is going to be down low where you are or where the plants are. That's why if you raise the roof, you get a bigger temperature rise, the hot air stays up there and is moved outward. I think that's fundamentally the difference between the outside temperature and the inside temperature also drives or makes the air move more quickly or slowly. So in the wintertime when it's very cold outside, then natural ventilation works well when you're trying to maintain a 70 or 75 degree air temperature in the greenhouse. The challenge becomes in the summer when it's 80 degrees outside and you're trying to maintain a 75 degree temperature inside. With natural ventilation, it's just not possible. Okay, my last slide is that I was hoping that you would get a bit of an impression of the different types of systems that are based on the different designs of the greenhouse, size of the greenhouse, the length and width of whether it's a single bay or a multi-bay greenhouse, the type of glazing that you put on it, and how that affects your heating system and the design of that heating system. And we'll look at that in my next presentation tomorrow. And also the design of the cooling system, how the size and the insulation on the greenhouse affects that. With that, I think, yeah. If there is, I see there's a couple of minutes, and since I guess I'm the moderator for this session, I can ask if there are one or two questions. We're at almost 9:15 right now. Yes, right here. Okay, the question is about natural ventilation, and on the peak of the roof, why to have two openings. One that would open, let's say, if it's a north-south greenhouse, one that would open to the east, and the other that would open to the west. Unless you can guarantee the wind direction will always be the same, you want to have the possibility of closing one and opening the other, or if the wind is relatively still, opening them both so that you get a fall of cool air and a rise of hot air out of the other one. If the wind is in between in speed, you could open the windward one and force the air down inside. That becomes a concern about the strength of, the damage to it. But that's the reason. Yes, sir. The question is, do I recommend a Quonset greenhouse or the roof ventilated greenhouse? No, I don't recommend any based on what you need to grow your crop. If it's going to be a single bay greenhouse, then maybe a Quonset would be sufficient, and you would not necessarily have a ventilator on the roof. You would have pad and fan for cooling. The question is, where is the industry going relative to the systems that I just talked to you about? I'm demonstrating those that have functioned in the past and will function into the future. There are new systems such as the closed greenhouse design or using alternative energies. What you need to do, my opinion, is to look at that alternative energy system. If it's providing you heat, then can it be modified to fit into your heating system, or do you have to rebuild that? I think it can be. You need a source of warm water. I'll talk about that in energy conservation in the next talk. For cooling systems, I don't know of any new systems other than what we just discussed, except maybe I didn't show you the semi-closed greenhouse, a very intensive use of energy to recycle the air in the greenhouse like you do in a building and cool it, keep the CO2 levels up, dehumidify it, and reintroduce it into the greenhouse. It costs a lot of fan capacity power, but it can make sense in a number of situations. Okay, the deal is this. I have to go. We have to introduce the next speaker. We have to move on to the next subject. I will be here all week. There will be times when we'll have coffee together. Please, my name is Gene. Come and see me. Be glad to talk to you and dwell on these particular subjects that I couldn't get much detail in right now. All right? Thank you very much. Okay.
Tell that everyone wants access to the internet. All right, thank you, Gene. So, getting onto the internet, the password is going to be MarchMup. I know it's odd. Capital M on March, no space, M-U-P. If you forget that, I'll be walking around, so just grab me, but that'll let you in. It's Myles.
Okay, our next speaker is here, I'm glad to say. Despite 4 days of intensive lettuce production, we'll see how he does today after, to be seen. Myles is going to talk about, first of all, he's the owner of the Arizona Vegetable Company. He's an instructor at our research center for our intensive hydroponic course, particularly focusing on lettuce. And he's going to be our first introduction to hydroponics, nutrient delivery systems, and even some root zone materials. Is that correct?
Yeah.
Okay. He just found out what he's going to speak about, and now he knows. Myles?
Go to it. I got a mic.
Okay.
I'm mic'd up. Use the clicker. Is there a laser pointer? Testing. Everyone got me? All right. My name's Myles Lewis. I'm of the Arizona Vegetable Company. I've been talking for the last 40 hours about hydroponics, so we're going to do another hour. I'm here today to talk to you about hydroponics in general, the medium composition, and then some delivery systems associated with it. So hydroponics, it's an agricultural method for growing plants or other organisms in an inert substrate with mineral-rich nutrition. A basic definition. And so hydroponics has some advantages and disadvantages to it. Some obvious advantages are that it has lots of water savings. Is someone lost? I know I am. Anyway, for example, I'm a lettuce guy traditionally, so I think of lettuce. In the field, the numbers that have been provided to us by folks in Univ, California, it takes approximately 50 to 100 gallons of water per head of lettuce before it hits your table. In hydroponics and greenhouses, the way we're growing and the way you're going to be learning, we're using approximately half a gallon to 1 gallon of water. So it's a significant water savings. At the same time, we're utilizing fertilizers very, very efficiently compared to what would be going on in the field. We get higher quality produce, higher yields, better, faster, stronger. Some of the disadvantages, though, is that there's expertise required, and that's why you're all in this room, is because it's a barrier to entry. If you guys don't know what you're doing, you're not going to be able to get into it. So that's a competitive advantage for me. But also there's a capital requirement. 10x yield per unit area is what's estimated when you go into greenhouses and hydroponics and CEA type scenarios. But at the same time, it's going to be a 10x cost. There's going to be fertilizer shortages at some point. Sometimes you hear of this concept called peak oil. Well, there's also this concept called peak phosphorus, in which the maximum amount of phosphorus we can get is sort of kind of going on the other end. So we're going to start having to get really creative. Beyond just that type of fertilizer shortage, there also is the fertilizer shortage of I don't have access to my fertilizer. A lot of the times we're going to be using things like potassium nitrate, which is now a controlled substance. So if I have difficulty getting a hold of it, that is a fertilizer shortage for me. Again, talking about the competitive advantages, which is going to be something for all you guys, you have to know how to do this. This isn't a very intuitive type of production system. Most of these processes are not well defined. There's some peer-reviewed literature out there, but this is a relatively new industry. People have been dirt farming for thousands of years. It's very well documented. We're all just starting to get into the hydroponics and CEA in the last 20, 30, 40 years. So there's the development of the databases that can be found, but largely it's a trade secret type of thing. People hold on to that information pretty tight because they've invested a lot of money. The Monsantos, the Eurofreshes, the Nature Sweets. They spend a lot of money trying to find out this information, so it's not readily available to everybody. That's their competitive advantage. So if we don't have arable land, that's not a problem. In case you can't tell what's wrong with me, I'm from Los Angeles, and so that's the perspective I'm thinking of. I've got power and water and some land, and so I think I can grow greenhouse produce over there. It doesn't require arable land. I can recapture areas such as brownfields. Again, I'm thinking about Los Angeles, areas that have been demolished, oil spills, the old gas station. We can cover those with some sort of geomembrane, build a greenhouse on top, and keep what's in the ground, and what's in the greenhouse is still safe to produce. Of course, the urban agriculture movement is moving pretty fast. I think that's largely why we're all here. And then soon you're going to start hearing about space. Maybe Elon Musk will be teaming up with Dr. Giacomelli to do the lunar greenhouse, we hope. The soil-borne pest problem kind of goes away. Usually you're concerned about overwintering in the fields and things of that nature. That goes away now because we're in greenhouses. We don't have to worry about those types of pest pressures anymore. We have all these types of protection. We're doing geomembranes, ground covers, so the weeds stay in the ground, the bugs stay in the ground. It looks like a hospital. It's very, very clean. So we like that. It'll, of course, cost money, 10x per unit area. So it's going to require significant capital investment, $600,000, $1 million per acre. So you better be prepared to invest some capital in this type of event. You're also going to have higher operational costs. Your energy requirements, your talent requirements, those will all be higher as you go into this because you need special talent. Yeah, we're not growing iceberg with this stuff. Maybe in India you would grow iceberg because iceberg lettuce in India seems to be a rising popular product. But in America, we know that's the cheapest of the cheap. So we're not doing the Ford Pintos of the vegetable world in our high-cost production system. We're going to be doing lettuces, gourmet lettuces, tomatoes, melons, other high-value economic crops. We're not talking about the C word in here. When I say hydroponics, you guys say vegetables. Hydroponics, vegetables. Excellent. And so plants can be affected by many things in the greenhouse and outside of the greenhouse in your production system. The temperature, relative humidity, light intensity, the mineral nutrition, carbon dioxide content, the dissolved oxygen content. These are all things that can affect your plants. Bad vibes, man. No. So what does the plant need? What are you trying to provide to the plant? Well, water is pretty critical. We know that. We're looking for some light so it can do some photosynthesis. That can be in the sun or via a light bulb of some form. The inorganic mineral nutrition could be organic, but that's a subject for Dr. Tollefson to discuss. Carbon dioxide, again, another critical component of photosynthesis. And of course, the support system for the plant as well as the proper humidity and proper humidity and temperature. There we go. So what types of hydroponic systems are out there? Well, you can slice and dice it in a few different ways. There's liquid culture in which the plants are suspended in a liquid mineral-rich nutrient solution. There's also aggregate culture where things will grow into a substrate, whether it be inert or not. Tomatoes, peppers, cucumbers, vining crops would be an example of something that would go into an aggregate culture because you're going to be growing into a substrate. And then commonly things like basils and lettuces and microgreens would be something that would be going into a liquid culture. That's not to say that you can't do the opposite, but you might want to just consider it for the ergonomics of production. Does it make sense to grow it that way? How are you going to access that plant and interact with it? Okay. Well, you can also have open and closed systems at the same time. An open system is which the nutrient solution, the fertilizer water, is going to be dispensed to the plant and then drains to waste. It goes out to the sewer, to a pond, somewhere else. It's not being recirculated within the plants. Then you also have closed nutrient systems in which the water is going to be recirculating. In that case, because you're not draining to waste and replenishing with new solution, you're concerned about things like filtration and and making the nutrient solution such that you're balancing the chemistry of it because the plants are going to be pulling up minerals as they're growing. You need to replace those as they're sucked up if you're going to be recirculating. Otherwise, you get nutrient deficiencies. Come on. There we go. There's also passive and active systems. A passive system, something in the effect of a Kratky type system. Dr. Kratky out of the University of Hawaii. He has the set it and forget it Ron Popeil lettuce system. I put lettuce on water, I leave it be, it grows, and everything's great. Alternatively, there's the active systems, which will be requiring some sort of electrical input or other type of power. They're going to need pumps and chillers, air bubblers, things of that nature to keep the system running. If I don't have those, I can't recirculate. That's particularly important in things like aquaponics, NFT systems, and aeroponics, where if the water were to shut off, you have a very limited time to sit there and correct your problem. You need to get the water flowing. And so that's where these active systems can sometimes be challenging. You need to have backup power for some of them. So then substrate. The substrate is just a surface that a plant, animal, or other organism will live and grow upon. Hopefully, we in hydroponics are going to have something that's inert. We don't like to have anything in it. We're control freaks, so we want to know what's in it, what's not in it. I want to have complete control of that, as opposed to soil, where you may or may not have control of that. What you get is what you get. So we have soil and soil-less. Soil is effectively a non-renewable resource. It takes a really, really long time to develop. So for that purpose, think of it as a non-renewable resource. It's composed primarily of minerals, organic materials such as decayed plant matter, other animals that have decayed over time, humus, animal waste, things of that nature. It also has air and water, and then there's also a microbiome in there. So there's bacteria, good and bad in there, other microorganisms. So it's a very diverse system. It's great because it's free, it's natural. I can go outside and dig soil up anytime I want. But at the same time, I don't know what I'm starting with. There could be disease, there could be pests. And then if anyone's ever picked up a soil map before, you know that you can walk in 3 different places and get completely 3 different types of soils. So it can be very variable, which we don't want. We want uniformity within our substrates, environments, growing systems. Uniformity is key. The quality of the soil will depend. You can have a clay soil, a loamy soil, a silty soil, a sandy soil, or any combination thereof. And of course, the composition of the soil will affect not only the water holding content, but the cation exchange capacity, the ability of it to hold fertilizer charges and then release it to the plants for them to use. There are soilless alternatives, which is what we're primarily concerned about. We like inert mediums that are ready to go and have nothing in them. They're most of the time sterile and oftentimes will have no fertilizer charge whatsoever, with the exception of some newer materials. Common examples are rock wool, perlite, vermiculite, coconut core, sand, gravel. So perlite, that's that kind of white popcorny rock that you think of, looks like Rice Krispies. It's inert. A lot of these are based off volcanic rocks. They're superheated rocks that have been treated in a different way to either popcorn out like perlite, to become a superheated fiber like rock wool, or to expand like vermiculite does. A lot of basaltic volcanic rock involved. Perlite and vermiculite are pretty close to each other. Both of them are inert. I would highly recommend that you use some personal protective equipment when handling these, especially perlite, just because of the dust that's associated with it. If you don't have a dust mask, be sure to wet it down before you're using it. But it's a very good medium. It's been used for a long time. It does very little cation exchange capacity, both vermiculite and perlite. Very fast draining, though. So if you're going to be doing a 100% perlite culture, just be aware that you're going to have significant irrigation demands because it doesn't hold water. Same thing with vermiculite, but I would highly recommend against anyone doing a 100% vermiculite culture. I would not do that. We've found that it has sometimes the ability to retain nutrients and then suck them out of solution, which is a bad thing. Rock wool is the gold standard. It's also inert. You want to flush that before using. Sometimes they have a binding agent or a wetting agent in there that you would just like to get rid of. And sometimes I believe they've gone away from doing rock wool based starch additions. So the wetting agent should be gone now, but you still want to rinse out manufacturing dust. Coconut core is one of the newer materials. I believe Dr. Jensen helped to introduce that to America at some level. Rinse it before using. Why? It's going to have a lot of salt in it. Where are a lot of these things coming from? Well, where do they grow coconuts? Probably near the coast. I'm thinking Hawaii, Sri Lanka, Mexico, some of the islands. And so the coastal areas, it'll pick up a lot of sea salt. And so you want to rinse that out. You want to be getting approximately a 0.5 EC in there. And of course, there's sand and gravel, which I don't think any of us will be using with the exception of maybe being in the Middle East. And even then, I don't know. So perlite. Again, an amorphous volcanic glass that's superheated. You can use it alone if you want to do 100% perlite culture, like I said, but usually it's added as some sort of agent to amend the content of the substrate you're already using. I have a substrate like coconut core. I would like to add more porosity and drainage to it, so I'm going to cut it with maybe 20, 30, 40, 50% perlite. It'll help prevent water loss and soil compaction. Don't forget the PPE. It's a relatively cheap item. I'm paying approximately $15 for a 3.5 cubic foot bag, which is about the size of one of these chairs, more or less, for a subjective comparison. Don't forget, though, it's got a low CEC. It won't hold the fertilizer charge, and it will dry out very, very quickly, so be aware of your irrigation requirements. Rockwool, again, that's the gold standard in hydroponics. You hear about it all over the Netherlands if you ever go there. We were using it for a long time. People are still using it, but we're moving on to other substrates. Rockwool is still great. I love Rockwool. I still use it. Again, another one of these superheated basaltic rocks, and then it's spun out into a fiber. If anyone's ever handled or laid insulation, fiberglass insulation, this will have a striking resemblance to it. You're going to be itching like you wouldn't believe. So I'd recommend wetting it down before you start to handle it. You cannot reuse it. You can reuse it, but you should not reuse it. I wouldn't recommend that because there will be roots and contaminants and other things like that. Sometimes you'll hear people say that you can just throw it away freely. At the small scale, I think you can dump it. But at a large scale, if you were to be a Monsanto or a Nature Suite or anything above, half acre, 1 acre, you're going to be dealing with dumping fees at some level because this is a non-compostable, non-biodegradable product. It's a rock. So there's going to be dumping fees associated with it, so please be aware of that. Coconut core. We all know what the coconut is. We imagine the coconut when we're getting a drink at the bar. It's that round thing. Well, there's also this giant husk associated with it, which is what's cut off before we ever see the coconut. And so if you can imagine it, coconut husks are building up in all these places where they build coconuts, or where they grow coconuts. And so what they did was they figured they could grind it up, and it acts as a fantastic hydroponic medium. It's relatively cheap. It's readily available. We think it has some disease resistance properties. Resistance, it's not going to cure things or prevent it, but it might help fight some things off. It's going to have that high salt content, so don't forget to leach it out. You're going to be looking for a maximum of 0.5 decisiemens per meter as an EC, leaching it with fresh water. And of course, it's compostable and disposable. And then there's newer materials coming out, hydrogen or leca pellets. There's composite materials like Jiffy Performa. There's, of course, Sunshine Mix, Pro Mix, lots of these soilless blends. A lot of these were the same price. I happen to be using Jiffy Performa right now. I'm also using Rockwool and Oasis at the same time. Each one's got its own nice little features to it. There's also other materials. One company is called Sure to Grow. I haven't seen them in a while, but there's other companies out there, and they're looking at these recycled plastics to be used as a media as well. Maybe a thin mat for growing greens on. I believe Aero Farms out of New Jersey uses some product very similar to this. So what do we care, or why do we care? Well, healthy plants are going to be the key to having a successful production system. If I don't have healthy plants that are strong, uniform in size, lacking disease, lacking some other sort of disorder, I'm probably not going to have a very good production later on. So picking the appropriate substrate for the organism, the production system, your location in that greenhouse will help ensure that plant's quality. And so what makes a good transplant? Well, we're going to start with good quality seed, of course. I want clean soil or soil-less inert media, of course. Clean pots, a clean area to start. Not inside your greenhouse necessarily, maybe a head house or a propagation area. I want the correct environmental conditions, a good fertilizer regime, and I'm going to be using good techniques to plant and transplant. There's an example of some really nice seedlings. I really like these because they're uniform in size. I got a very good stand all the way across, so I used high quality seed, a very good substrate. I had good handling practices, and I provided the proper environmental conditions for this plant. And so consequently, I've got a 100% stand right there, 100% usable. Again, another good set of plants. Rockwool on the left, Oasis on the right. Uniform. So these are all very good plants. I'm pretty happy with these. Here's some selected substrate companies. This is not a complete list, but here is a list of people who manufacture some of the substrates in various sizes. Premier Tech, Jiffy, Thermarock, Annapolis, Sungrow, so on and so forth. And so manufacturers will make different materials. Some of them only make one. They also come in lots of different sizes. So anything below a 55 cubic foot tote is probably something the rest of us can handle. If it's above that 3.5 cubic foot tote, we might need a forklift or 20 guys or something like that, because these are 10-foot tall bales that weigh about 1,000 pounds. So in case you've already got your hernia, this is not the activity for you. Get a forklift. I have 2 hernias. Yeah, this is a dangerous industry, guys. Be aware of what you're getting into. So when you've picked your substrate out and you've picked your seeds out, you're going to put it in some sort of tray or container. In general, there's 3 types of trays: the 1020 tray, injection molded trays, and EPS trays, expanded polystyrene. There's a lot of different sizes, cell sizes, shapes, compositions, numbers of cells, so you can pretty much get it any way you would like. Here's some manufacturers: Beaver Plastics, Plantel, Speedling, Beltwide. Kimplug is a different one. The 1020 tray, how did it get its name? Well, it's the dimensions, 10 inches by 20 inches. And that's the most standard issue tray that you're going to see hanging out. It's about yay big, by that, it's black. Everybody's seen these things. The injection molded trays right here are a more rigid plastic that are more able to withstand cleaning. Sorry, I've got people waving at me in the back. The EPS trays right down here are the expanded polystyrene. So a Speedling tray or a Beaver Plastics tray. I need a Kleenex. No, I need a tissue. I need a Band-Aid. No, I need a bandage. I need a Speedling tray. No, I need an EPS tray. So there's, if you hear Speedling tray, it really means EPS. And there's other manufacturers like Beaver Plastics. There we go. So then the formal types of hydroponic systems. It seems like every day somebody's coming out with a new name for a hydroponic system that they came up with because they want to, be special and feel good. Formally, though, there's the NFT system, nutrient film technique. There's aeroponics. There's the bag culture, which is the top drip or the aggregate culture. Ebb and flow, deep flow, and then aquaponics. I've heard all sorts of different names. I've heard bubbleponics, duckaponics, fogaponics, but generally these are all the ones that are commonly used, and they are all subsets of hydroponics. Do you grow hydroponically? No, I grow aeroponically. No, you grow hydroponically. That's just one way of doing it. So what kind of system should I use or should I get? I'm not answering that question for you. I don't want to be held responsible. But what I would encourage you to consider is, what are you growing? Is it a tomato, something that's going to need a taller greenhouse and support systems and clips and twines and things like that? Alternatively, maybe it's going to be a lettuce or an herb, which might be a freestanding lower crop in which you don't need as much system or greenhouse. Where are you growing? Your site location might determine that you need one type of system versus another. If I was to be growing on a rooftop, I probably don't want to have a deep flow system in there because water weighs 8.34 pounds per gallon. So if you can imagine it, putting 2,300, 2,500, 4,000 or 5,000 pounds on top of a roof could be really challenging. It might require a lot of retrofitting and infrastructure modification. So I might choose an NFT system in that type of case. If I know I have lots of power outages, maybe I'm going to be considering a deep flow system for some of my other things. So just encouraging you to think about where you're growing. In addition, how much do you need to grow? What's the production frequency? What are the production cycles? How much do you need to get out of there? So these are some of the things that you should think about. And then as well, can you just use all what you just bought? Or did you just put yourself out of the bank? Don't buy more than you can use. It's really easy to buy all the bells and whistles, which are completely useless at the beginning point of your production cycle. So just be aware that you can overspend. Some other things you can grow. We always hear about lettuce and tomatoes and cucumbers. We're all kind of sick at that point, and we're looking to move on. I can grow kohlrabi, Swiss chard, green onions, chives, basils, radishes, microgreens, melons, strawberries, flowers. So there's lots of different crops that can be going into all these systems. So you can think outside the box of just lettuce and tomatoes. An NFT system, nutrient film technique. A constant stream of water is running through roots. Nutrient film, so a very thin layer of water is just constantly running down, going by the roots. The roots are sucking up the water. It's not floating in the water. But that implies a recirculating system that's going to be constantly running 24 hours a day. It's a very lightweight, space-efficient, relatively simple system. Use it for rooftops, use it for lettuce production. I don't know that I would put tomatoes in there necessarily, but Maybe you want to. There's going to be limited spans. You're not going to have a span of NFTs running the width of this room. There's going to be things like temperature, pH, EC fluctuations as the water travels from one point down to the end. So you want to be aware of that. I could have a completely different composition of the water from one end of my greenhouse to the other. So you're going to want limited spans, 10 feet, 20 feet, 30 feet. I don't believe I've ever seen anything above 50 feet. So I believe that would be my maximum number, but that would be a good question for, say, a Dr. Jensen. How many feet can I run? That's an example of it. It's a relatively simple system. If you can imagine, this would be like a rain gutter. So I've got my water coming in, and then it circulates back out. I've got a water pump down here and a reservoir. Water comes in, drips, goes back, and then it just recirculates over and over again. Here's an example in real life. Water's coming in, drains out, and then recirculates. So it's very nice because it's a very highly efficient water using system. I only have water loss coming out of the surface of the substrate that's exposed to the air, and then the transpiration coming out of the plant. So I've really eliminated a lot of the runoff, infiltration of the ground, evaporation from surface water, so that's how it's so efficient. Aeroponic, the nutrient solution is held in a reservoir. Reservoirs are common to all these pretty much. But the nutrient solution is held in a reservoir, and more or less I just have a sprinkler system, bathing my roots constantly. It's constantly bathing the roots. Shoots are generally going to be on the outside of this system, roots on the inside. And so this is more of a system geared towards root crops, medicinal crops, ginseng, stinging nettles, turmeric, things of that nature. Can I grow other plants on there? Absolutely. Does it make sense for you to do that in your production system to max out whatever you'd like to be doing? Not so sure. You got to answer that question yourself. High oxygen content, which is really nice because it's bathing in free air. The roots are just hanging down in this solution. There's an example that we built. We did an A-frame in this case. This was just kind of a club activity, but it demonstrates the concepts of aeroponics. We have a reservoir containing our nutrient-rich water. We have a water pump, a sprinkler system, and then on the inside of this A-frame is going to be the roots hanging on the inside, being bathed by this sprinkler system hanging in the reservoir. And then on the outside is going to be my shoots, the top of the plant. Ebb and flood. Ebb, flood, ebb, flood. So it's going to flood and drain basically. It can run on a timer, it can run on light, it can be a bunch of different ways. You're still going to have the reservoir, a water pump, a controller reservoir, and then some sort of bed. This can be modified into a floating hydroponic system if you just simply put a plug in there or just run a lot of water. It's really nice with the exception of when my exposed surfaces are covered in fertilizer water after I've drained it, there's a lot of algae accumulation. So I seem to have a little bit more maintenance activity spraying my tables down, but it's a very good system for propagation, if I want sub-irrigation, if I would like to do greens where I'm not having water splashing on the top, it's a very good system. There's an example of it. This was Dr. Cherry Kubota. This was her greenhouse at a time. She was producing small greens, mustard, Asian greens, Mizuna, things of that nature. So she grew in, I believe, 10, 20 trays in perlite on top of the table. She would flood it and then drain it. It went about every 30 minutes, I think. The frequency is up to you guys. You have to watch what the water demand is for your plants. Deep flow, that's what I just got done talking about for 4 days. It's very easy to manage. It's pretty easy to maintain mechanically. Ideally, it's for leafy crops and transplants. I'm not necessarily going to grow a tomato in there to fruition. Can I? Yes. Does it make sense for me to do that? Not really, because I'm going to be going for a swim at some point when I try to go reach in and grab my tomatoes. It can be difficult to maintain the nutrients and the aeration depending on how large your pond gets. If I have a very small pond, 4 by 8, that's pretty easy to maintain. Once I get into the lake and pond size things, it can be challenging. That's a lot of water to deal with. Another challenge is the disease. We're all drinking the same water, so if I'm recirculating the water within this system and I have one plant that's got a disease and it's putting the inoculum into the water, everybody's exposed to it. So your control of disease, pressure could be a little bit different in this type of system as opposed to a bag culture of tomato. If I have one bag of tomatoes that's starting to show a problem, I can just simply remove that bag of tomatoes and everything else is still okay. If I have one plant that's sick in the lettuce production system or an herb production system, it could potentially infect everything. I'm using a pond, styrofoam floats or plastic floats as they're coming out now, an aerator, a circulation pump, a chiller or heater, depending on your location, to alter the water temperature. But that's how the big guys are doing it. TNA, Hydronov, these are very large companies that have 16, 17-acre ponds. So lots of water mass, lots of plant production. There's a very rudimentary example of it. I've got a reservoir containing my nutrient-rich solution, which is being aerated and controlled for temperature. I've got a styrofoam raft right there to hold my plants, and then the plants. There we go. Don't put animations in your PowerPoint. Again, the same thing with the preventing water loss. I've reduced my surfaces for evaporation. It's really only a perimeter inch, where I've got a little bit of exposed surface. I've got a lot of buffer against power outage. If my power goes out, that's okay, because my plants are still floating in water. So I like that. I don't have to necessarily have big backup systems. I have a little bit more time than compared to NFT, aeroponics, aquaponics, which are very, very active systems. Again, the downside is that there could be a disease because we're all drinking the same water. There's also going to be nutrient accumulation and deficiencies over time. I don't know what the plants are taking up necessarily and what they're not taking up. And because we have so many different stages of life growing within the system, it's arguable that they're putting out and taking up nutrients at a different rate. Babies consume baby food. We're all consuming the buffet outside. So we have different nutritional requirements, so it would be arguable they will as well. So just topping off isn't necessarily the easiest solution. You're going to eventually have a problem over time. And of course, you sometimes will get a little bit of algae growth. My middle name is algae. Here's an example of it. Within these types of systems, we really like the uniformity of temperatures, solution temperature, pH, EC, and dissolved oxygen, because it's very easy to get pockets within these systems. Acid is generally heavier than water, so it can sink to the bottom. So if I don't mix very well, I could have a very thin layer of acid, like a heavy water concept, and then I can have a pH of 2 and then a pH of 7 up here. So I want to make sure I have good mixing. I don't want pockets of varying temperature throughout my system. And so I have a distribution manifold right here. I have a circulation pump, and then I've got a chilling probe. So I'm trying to maintain solution temperature. In this case, I wasn't concerned about pH and EC. There we go. Again, I'm a lettuce guy most of the time, so I'm just going to give you a lettuce example right now. It's using water super, super efficiently. If you put me on a lab bench, or depending on which shade of glasses you like to look at my water use efficiency, I could be using as little as 2 to 3 liters per head of lettuce. That's water consumed. There's still processing water, there's still germination water, there's still the water that goes into the evaporative cooling pad, but I'm simply referring to growing water by comparison to what the folks in Salinas, Imperial Valley, and Yuma are consuming, which is anywhere from 175 to 375 liters per head. So significant water savings. Does anyone care right now? No. But they will once water starts becoming a limited resource, or they shut off the CEAC access to southern Arizona. Just food for thought. Where is 90% of the lettuce in the United States grown? Yuma, Imperial Valley, and Salinas. Well, gosh, I'm from California. I could have sworn they just had a drought. Gosh, I'm in Arizona right now. I could swear that we're in the middle of a desert at the end of the CEAC. So it's kind of counterintuitive that we're growing this super water-intensive crop in places that don't have a ton of water. So I think as people become more aware of that, the hydroponic production of a lot of these vegetables will become more important. Higher quality. I can do it locally. I have power. I have water. I have some form of light. I can grow plants. It's kind of cool, too, because a lot of these systems can use traditionally unskilled labor. Unskilled being a person who's not trained in this, a person with developmental disabilities. So there's lots of other labor that you can use into this. You don't have to worry about being able to drive a tractor or apply pesticides. Can I move plants like this? Can I pick a tomato? Can I point out bugs? aquaponic, that's going to be the culture of fish and plants in the same type of system. The fish are going to be using a standard protein feed because I want consistent fertility coming out of the fish. The fish is my fertilizer source. I have no other fertility going in there in general. So if I'm giving the fish a different diet every day, it's arguable that the waste product coming out of the fish is going to be of a different quality and consistency each time, and that's not what we want. It's a disgusting example, but if I was to eat Taco Bell and then McDonald's and then go have a salad and then eat a steak, you could argue that the waste products coming out of my body are going to vary in consistency. Whereas if you just gave me macaroni and cheese 365 days a year, the waste products would be the same. And again, that's what we're shooting for. We want consistency within our systems. We want the uniformity of everything. Now, that's a disgusting example. Hey, it hits home, doesn't it? You're all resonating with it. The fish waste fertilizes the plants take out the waste from the water so the fish can live it, so it's a nice symbiotic system that's really neat. It's simple in concept, but it's pretty complicated because now all of a sudden I've interjected a fish into the equation. The fish likes one set of conditions, the plants like another set of conditions. So the fish are going to like a higher pH and a lower EC. Well, that's not very convenient for my plants, which want to be a lower pH and maybe a little bit higher EC. So you're kind of fighting with each other. So I think the important question to ask yourself is, what's the product what's the product you want coming out of your aquaponic system? Do you want the fish or do you want the plants? Because a lot of people sit there and they do both and they say, yeah, it's time to harvest Jaws over there. He's looking really tasty. We're going to go have a fish fry. Well, if you take the fish out, you just lost your fertility source. So, now you're going to be setting yourself back in plant production. So make a choice. If you want the fish, I would recommend you do aquaculture. Grow the fish for the fish. If you want to grow plants, that's fine, but just be prepared not to take the fish out of here and it's an aesthetically pleasing thing to watch like the koi pond. 24/7 power, again, because this is fish. We have living organisms in here, bless you. And so we need filters and aerators and pumps. And in the case of our aquaponic system here at the University of Arizona, we actually have a transfer switch hooked up to an oxygen tank so that if the power goes out and everything goes wrong, an oxygen tank will click on to feed oxygen into the solution so that the fish don't die. There's an example of it. Fish swimming around. And then if you can imagine it, the water's circulating out into a lettuce pond in this case. There we go. 5 minutes? I'm going to start speaking really, really quick. All right. Bag culture. That's tomatoes, peppers, cucumbers, things of that nature. Don't forget to get a lysimeter. You want to be measuring the input and the output coming out of your solution. That'll help you steer the plant, understand plant health and usage of water and fertilizer. The Kubo system, kind of standard issue in the Netherlands right now. I got my bag. I'm growing tomatoes out of it. Water goes in and then drains out. In this case, they're in the Netherlands, so if you ain't Dutch, you ain't much. Sorry. That was the joke of the week right over here. But anyway, they're more than likely recirculating, but alternatively, it can be a drain-to-away system like what we do here at the U of A. These are all the pieces of equipment inside your greenhouse that can possibly be interacting with all the pieces of equipment that you have. I'm not going to read that off in the sake of time. We'll wait for that gentleman in the back to take a picture. All right. You're going to look for controllers in the greenhouse. I believe Dr. G might have alluded to this, but you're generally going to have the analog or the digital ones. Something with a GUI, something without a GUI, something with high resolution and very fine control, or the old thermostat on your grandma's house that just does a temperature of 55 degrees. Here's an example of a GUI. It tells me things like carbon dioxide content, relative humidity, PAR, air temperature, pH, EC, all the things that are going on inside my nutrient systems. There's going to be a lot of sensors that you're concerned about. These are the things that are going to be in your tanks, in your greenhouse, that are going to be helping you control and steer the plants. Air temperature, solution temperature, relative humidity, carbon dioxide, EC, pH, nutrient content. So, don't forget that the plant quality and health can be affected by all these different things, and that's what we want the sensors to be telling us and looking at it for us. Disease susceptibility, pest pressure, the size of the product, time to maturity, bolting, the aesthetics, texture, taste, color. These are all things that can be affected by your growing systems. There's an example of a passive fertigation system, a dosatron system. There's also very active systems which will require electric power, air compressors, filters, things of that nature. So passive and active stays true for not only the production system, but also your fertigation system as well. There's also automatic seeders, which you may or may not want to consider. My automatic seeder is sitting outside at that table. You met him. His name's Iron. Your greenhouse, we know what that is. Don't forget to put the ground cover in there. 1% light loss is 1% loss of yield, so we want to be reflecting light back up into the greenhouse. I would recommend that all of you go home and do some sort of substrate analysis to see what substrate is good for you guys and works with your plants and your system. And I would encourage you to do a variety trial as well. You can grow lots of really neat things in these types of systems, so beyond just lettuce and tomatoes and cucumbers. Chives, green onions. Get about 2 to 4 pounds every 60 or 70 days. Some beautiful lettuce, of course. Now I'm just getting arrogant. But anyway, you're going to have a lot of problems, and hopefully you can turn them into something that will work for you. So I went and captured this guy before I got stung by him, and I've been feeding him insects for a while. But anyway, that's an Arizona problem. Whew. Barely made it. Questions?
Are there any questions? I assume there would be.
I wanted to ask for algae management, for the deep flow systems. How do you manage those?
So a couple different ways. How do I manage my algae? One is I have running water. You never see a lot of algae growing on streams that are running. So if you have some recirculation, that helps a lot, so flowing water. Largely, it's chemical control for me. In my case, I'm using a product called Oxidate. It's also known as Sanidate or Xeritol. It's the hydrogen peroxide chemistries. And you'll just be injecting that in line at a more dilute rate, or alternatively, you go around and you spray the algae when you see it. You can use UV filtration as well, but that's relying upon making sure you have ultra clear water, which algae might not do that. So I would look at chemical control with one of the hydrogen peroxide type chemistries.
Myles over here.
Ma'am.
Myles, you spoke about significantly higher yields and higher quality in your system. I was wondering if you could speak about how you were measuring those results, or what the results were that you saw at your farm.
Okay. How am I measuring these things? Well, the easiest way that I measure it is by quantity and weight, and then the frequency that I'm pulling it out. So I'm pulling out X many heads of lettuce or X tomatoes at a higher frequency. I'm measuring the weight of the head compared to what the literature says or what I can purchase at a supermarket. I can do measurements such as Brix tests, so I'm going to be measuring the total total soluble solids within there, basically the sugar content of the fruit. You can also do Brix on lettuce, but we all know lettuce is not the sweetest thing in the world. You can send things off for analysis. So if I wanted to look at the carotenoid or anthocyanin content, the vitamin A's and the vitamins contained within the plant, like the redder the better, the greener the better type thing, I can send that off to a lab for analysis to quantify that. And then otherwise, it's really kind of subjective stuff. I think this plant looks healthier than the other one. I think this plant has a greater color than the other plants. So some of it's subjective, some laboratory.
Other questions?
Thank you. Is there a range of variability when you harvest it that you generally consider acceptable, or do you have a gold standard, for example, the weight of each head of lettuce that you pull? Is it within 10% of each other, or is 20% acceptable, or are there kind of industry benchmarks?
Industry benchmarks. So hopefully they sat there and said that the most annoying answer they're going to say to you is, it depends. And that's the common issue plant science answer, it depends. If you're selling by weight, there's going to be cutoff weights depending on the type of crop you're growing. So for example, and it's going to vary by location. The bigger lettuce producers I know are producing a 250 gram head of lettuce. My minimum cutoff weight is 150 grams, so it kind of depends on your market in that sense. Usually my plants, if I'm using good quality seed and I've got good transplants, the variability plant to plant within the production system is within 10%. Most everything is within range and very even. So I generally get very good uniformity. With respect to tomatoes and other things, again, the unfortunate thing is that depending on the variety is going to dictate what the cutoff weight or how you sell it is, so whether it's a unit or by weight. Tomatoes will have varying cutoff weights depending on whether it's a TOV, a grape, a cherry, things of that nature. So I'm sorry, it depends. Ma'am?
In the ebb and flow system, you talked about having issues with nutrient accumulation and leading to problems over time. Do you have a specific time for doing system cleanouts, or how do you avoid making that problem over time?
Okay. The nutrient accumulation. In general, I think I'm seeing that actually more in the floating hydroponic systems or the deep flow systems, but regardless. If I have a small volume, such as the ebb and flow table, where it's 1 to 100 gallons, I probably am going to be servicing everything every week or every 2 to 3 weeks. If I have, say, a 3-week crop cycle, I'm just going to service it every 3 weeks. In the case of the larger people, like I'm going to use their name for example, TNA out of Tennessee. I know that they're sitting there with large ponds, and they're servicing their ponds annually. So they'll be producing 20,000 heads of lettuce a day for an entire year, and then they'll shut down and then drain and then clean. So on the larger systems, it's annually. On the smaller systems, I would say monthly.
All right. Okay, so the next piece of information that's going to be super important to you no matter what you're growing is pest management. One thing real quick I want to let you know about is this website. This is fantastic reference material for you for any kind of pest issues that you might have. To take a look here, you can look under agricultural pests. You can look under agricultural pests, you can look under the type of thing that you're growing, whether it's tomato or lettuce. They give you a complete list of the different bugs that you'll find, the different diseases you'll find, and different ways to control them. It's not quite as good with biological treatment. It touches on things. You're better off with biological treatment to look at actual websites of companies like Copert and Biobest to look at your biological options. But this is really good for your chemical options. Okay, so first of all, how do you know if you have a pest problem? Well, you need to know what a healthy plant looks like before you know if you have a problem on your plant. And then you need to be actively scouting or looking for pests. So as a manager, either yourself or you're going to have to hire someone to deliberately go out, have a systematic way to look for these pests, look for the damage that they're causing, and then also have a way for your laborers to be able to report back to you anything that they happen to find, because they're in the crop every day. You'll be looking for actual pests. It could be the actual whiteflies, the aphids, or it could be just the damage that they've caused. And you'll be looking with your eyes. You'll be looking with a little lens. You can get these little 15x lenses that'll help you look closer up to see what you've got. Sticky cards are really good to catch your flyers. So you may not be in the crop every day, but the sticky cards are, so they can catch some things that you might not have seen. And then for some things, you might need to actually look under a microscope, so that's kind of handy to have. So the main pests that we're going to talk about today are the insects and mites, the most common ones that you're going to find in a greenhouse environment no matter where you're growing. And there's these insects, and there are two particular types of mites, spider mites and russet mites, that are of major concern. Now, before we start looking at the pests themselves, let's think about pests as a broad category, these insects and mites. Well, they're all arthropods. And arthropods all have an exoskeleton, or a semi-rigid armor made of chitin, and in order for them to grow, they have to molt. Now, these are very tiny, many times very tiny organisms. When you look at a cicada, you see a big shell. Well, when you look at an aphid, you see a very tiny cast skin of their molting. Sometimes you don't even see the moltings, like with the spider mite, very tiny. But they do molt to grow, and this is a way we can target to control their growth or to kill them. The other thing that's important is that all these arthropods breathe through their skin. They have holes in the skin for air exchange. So if we can use any type of oil, we can plug those air holes up and suffocate the pest. So any oils, the really important thing is you want to have good coverage. You need to spray, make sure you're hitting those pests in order to actually suffocate and kill them. The other thing to think about is how is it that these pests are harming your plant? And how are they feeding on the plant? And there are two major ways that they feed. Most of the pests that we have have piercing sucking mouth parts. So they have this pokey stylet, they pierce into the leaf tissue, and they're sucking the plant sap out for their nutrition. And they're mostly looking for nitrogen, and they're getting way more sugar than they need, and so a lot of times they're excreting sugar in the form of honeydew. And I'll explain that a bit in a little bit. And that's most of your insects, like your aphids, your whiteflies, your spider mites, tomato bugs, they all use piercing sucking mouth parts and pull that sap out. There are some bigger pests, your beetles, your grasshoppers, leaf miners, that have chewing mouth parts. So they're actually caterpillars. They're going to actually chew and make holes in your leaves. I have bees on here, not that the bees are hurting your plants, but they have chewing mouth parts. That's why I had that on there. And then you have thrips, which actually have both. So we have this rasping, scraping mouth part, and also the piercing, sucking mouth part. So of course, if you have chewers, they're going to actually make big holes in the leaves that you can see quickly. With the piercing, sucking mouth parts, when they pull that sap out, they could be pulling chlorophyll out, your growth hormones, and so it's going to imbalance the plant and its growth. Okay, so this can lead to your leaves could start to look yellow or have chlorosis. You could have spots on your leaves that end up dying because the plant sap is taken out. Stunted growth, deformed leaves. Overall, photosynthesis could be decreased by these insects or these mites. And many of these, especially with the piercing, sucking mouth parts, they can transmit viruses and diseases. So if there's one plant that has a virus or a disease and they feed from that plant, they could carry it to the next plant, and when they puncture that plant, they're going to deposit that virus or disease to the next plant. Okay, the other thing to think about is, what is IPM? What is integrated pest management? That's kind of the big thing now. Years ago, we sprayed, and now we've figured out it's harmful with all these chemicals. So IPM has become the new philosophy. It's the coordinated use of pest and environmental information with available pest control methods to prevent unacceptable levels of pest damagement. It needs to be economical and with the least potential hazard to people, property, and the environment. So one thing to note here is it's preventing unacceptable levels of pests. So that infers that there is perhaps a level of pests that you can be okay with. A lot of times for us, thrips are something that we see all the time in a tomato greenhouse, but they're usually at a level that they are not going to harm our production. And so we just let them be. So there's a tolerable level for thrips, and it's only until they get way damaging the leaves enough or damaging the fruit that I start to do some kind of a control method. Okay, so also integrated pest management does not necessarily mean organic pest management. So it's using all of the tools in your toolbox, but pesticides may be a piece of your plan. The main idea, though, is you want to try to control your pests with prevention first. Have your sanitation foot bath, have your insect screening, and so forth. But if you happen to get some pests that you need to control, the idea is to first try using beneficial insects. So bring the good guys in first to try to kill your bad guys. And then maybe use some oils or some botanicals first. Then, and also you want to make sure that those oils or botanicals that you use are compatible with beneficials if you're bringing those good guys in, so that it's not going to kill the good guys. Then if you can't get control using those methods, then you might need to go do a synthetic pesticide. And in a greenhouse situation, you have to be a bit careful, and we'll talk about that. So remember, especially with tomatoes or peppers, you will probably have bees working for you in your greenhouse. Well, we don't want to spray anything that's going to harm the bees. So we have to always be careful with that. And there are certain pesticides that are okay in a greenhouse on our crop that are okay for bees as long as you're not spraying them directly. So sometimes you got to get the bees to go home for a while you spray and then bring them back in. Now, with pesticides, you have to remember that the label is the law. So anytime you're going to use something, you got to look at the label for what protection gear that you need, what your dosage rates should be, whether it's okay for greenhouse use, whether it's okay for vegetable production, for your specific crop. The general rule is if it doesn't say you cannot use it in a greenhouse, you can use it in a greenhouse. Now, if you are an owner and a grower, then you would need to get your state growers permit in order to purchase pesticides and apply them. Then you will be able to apply anything on your property under that permit, except for restricted use pesticides. And there's a list that you get from the EPA that tells you what those chemicals are. In our case, for greenhouse use, there's really only two that we've ever used, and that's abamectin and imidacloprid. So those two, you would have to get certified, or one of your employees would have to get certified in order to use those two particular products. Okay, a couple abbreviations that I'm going to throw around. PPE is personal protection equipment. So that's the kind of gear that you need to have when you spray certain pesticides. That's on the label. REI. REI is the restricted entry interval. And so this is the time between when you spray your crop and the time you can come back into the greenhouse to work on the crop. So you can't be in the greenhouse for those hours. Many of them are 12 hours or 24 hours. So you put this sign on the door, and it says you can't come back in. None of your workers can come back in until the REI has been fulfilled. Then there's the PHI, and that is the pre-harvest interval. So this is the time between when you spray and when you're allowed to harvest that crop again. So in a greenhouse setting, we want chemicals that we're able to harvest again very quickly. Either a 0-day harvest restriction, maybe a 1-day harvest restriction, but we're usually harvesting, depending on the crop type, if it's tomatoes, once or twice a week. If it's cucumbers, especially minis, it could be every day. So you have to keep that in mind with the choices of chemicals that you might need to use. Okay, so now we're going to get into these particular pests that you will probably end up finding in your greenhouse at some point. So we're going to start with the mites, spider mites, or they're sometimes called the two-spotted spider mite. They come in different colors. They can be a red, they can be a greenish brown, but they usually have these two dark eyes or spots at the top of them. They feed on many different types of crops. They really like cucumbers and melons, strawberries, or particular problem with strawberries, for hops. Not as much for tomato, but you can find them on tomato, but they'll preferentially go to your cucumbers or your peppers first, usually. They like warmer and drier environments. So in Arizona, we get them quite a bit. Some signs that you have spider mites on your plants: before you even see any webbing, you might see this yellow stippling. Spider mites in particular pull out a lot of chlorophyll. And so they leave these little yellow spots on your leaves. So you might see that first. Then if you look right near where the petiole meets the blade, you might start to see a little bit of webbing, and then these little dots in the webbing. And they'll be little, moving around. You can see these with your naked eye. And what I always tell my students is, you know, sometimes we do get regular spiders in the greenhouse. So how do you know it's not a good guy? Well, if you see a lot of little things moving around, it's bad. That's spider mites. If you see one spider, it's probably a good guy. So if you see a lot of little things moving around, that's not good. Ways to control spider mites. Water is a good knockdown. It doesn't necessarily kill them, but it does knock them off the plant so that then you're able to bring in some beneficials to take care of them at an easier rate than having all the spider mites on there at one time. So once you kind of wash them off, you can wash them off once a week or twice a week until you get your beneficials in, and that'll help to control. But it won't get rid of them. Water's not going to be sufficient. You can use insecticidal soaps and oils. I've not found a lot of good luck with them, but biological control works quite well. There are 3 particular types of predatory mites that are really good for spider mites, listed here: P. persimilis, A. californicus, and the Swirsky mite. And you can order those through different companies. Now remember, when you order these beneficial predatory mites, they're going to take about a week to a week and a half for you to actually receive them, because you've got to order them. They have to order them from the Netherlands. They come here, and then they ship them to you. So you got to have some kind of control option in the meantime to help you until you get those beneficials in. And then anytime you use beneficials, there's a little lag time, because it's going to take a little while for those populations to build up and actually get control, whereas with a chemical, it's a quicker knockdown. So you want to keep that in mind. If you end up either using beneficials or you need a quicker knockdown, 2 products that are particularly good for spider mites are bifenazate and abamectin. Now, the nice thing about this acromite, that's the brand, one of the brand names, is that it's just a 3-day pre-harvest interval. So after 3 days, you can harvest again. Whereas with the abamectin, it's 7 days. So if you've got cucumbers, it's probably better to go with the bifenazate, because you'll be able to harvest quicker. Now the thing is too, that the abamectin, this is one of those that's a restricted use pesticide. So you're not going to be able to apply this unless you have a licensed applicator, or you hire somebody to come in and do that for you. Okay, so that's spider mites. Now russet mites are, they are very, very tiny. You are not going to see the russet mites with your naked eye, but you will see the damage that they cause. And you're going to see these on tomato. They can be on a few different other crops, but this is it's primarily tomato, and there's a different type for your medicinal crops. But there's no visible webbing, even though they do use a very fine webbing to move around. But you will see this reddish-brown coloring on the stem, and it typically starts from the bottom of the stem and works its way up the plant. And what happens is, as it moves up the plant, your main stem is getting brown, and then it goes out to each successive leaf, and it starts to dry it out and make it yellow. And then it goes to this next leaf, then the next one, and the next one, and pretty soon your plant is dead. It's not quite as fast-moving as spider mites. Spider mites, you need to get control pretty quickly. With russet mite, you have a little bit of time. Usually with tomatoes, we'll see maybe 1 or 2 plants that start to get it, and then next week we got another 3 or 4, and then next week another 5 or 6. So over a couple weeks, it's going to get worse. And then at that point, you don't want to spray just those plants. You want to spray your entire greenhouse, because they're probably around. If the population of the russet mites gets big enough, sometimes you will see these colonies that form. And so you'll see this brown fuzziness on a leaf or on the calyx, the green part on top of your tomato. They like to hang out there. If it gets worse, usually they just attack the stem and the leaves. If it gets really bad, they will attack the fruit, and you get this alligator appearance of dry patchiness on your fruits. Now, to verify that it's russet mite, because sometimes that browning on the stem could be simply because your plant's a little old, or perhaps some mechanical damage, rubbing. So to verify that you have russet mite, what you want to do is take a piece of electrical tape, and you want to wrap that electrical tape between where your brownness is and then where your healthy green part of the stem is, right at that interface, because that's where your mites are the most active. So you're going to wrap that electrical tape around there for a few seconds. You're not leaving it overnight or anything. For a few seconds, take it off, and you put that under the microscope. And what you would see if you have live russet mites is these juicy larvae-looking things. They're very tiny. If they're full, they're usually alive. If they look flatter, they could be dead. And a lot of times, you're going to see them kind of on their backs, and their little legs are going like this and moving. And then you know they're active and they're alive. This is a nice way to check if your treatment's been effective, because you can come in afterwards, a day or two later, do the same thing, and see if those russet mites are now dead. Now, with russet mite, number one, we don't have any biological options. They're too tiny, and we don't have any biologicals that can come in and treat them. So we have to use some kind of an oil or chemical option. Now, we have spot treated with neem oil and water, and it does okay if you just have maybe one plant. But if you get to the point where you've got more than one, it just ends up not controlling well enough. You can use sulfur. You can use a sulfur burner, but you have to be careful. If you have a polyethylene cover, it can degrade the cover. We don't like to use the sulfur burners also because we have bees, and it's detrimental to bees. But what you can do is get a powder, kind of a micronized sulfur that you can mix with water, and you can use that as a spray on the stems. The other thing is you can just do a dust of powder on the stems as well. That can be effective. If that doesn't give you control, and let's say you want to try oil, you want to be careful not to use sulfur and oil within about 20 to 30 days, or you can get some phytotoxic effect on your leaves, some burning, so you want to be careful with that. If you start getting more than like 3 plants that get spider mites, I would suggest treating the whole greenhouse and using abamectin. This really does a good job at stopping the spider mites in their tracks. Again, it's a 7-day harvest restriction though, so you got to keep that in mind. But usually we'll spray once with this and we're good for about 4 months without any more spider or russet mite problems. Okay, aphids. Now, so aphids are kind of bulbous shaped, and their key feature is they have these cornicles, or these tailpipes, at the backs of their abdomen. So sometimes you can see them very easily because they're darker. Sometimes they're the same color as their body, and it's really hard to see them, like these green peach aphids. Very hard to see the cornicles. But if you use your hand lens, you can look in there and you can see, you'll be able to find the cornicles and know that they are aphids. But usually they're quite big. They're one of the bigger insects that we see in the greenhouse, so you can see them with your naked eye quite easily, except sometimes when they're the same color of the leaf, then you may miss them. They can be winged or wingless. Most of the time in a greenhouse setting, they do not have wings unless the population gets so big that they need to fly to another plant to feed, then they will develop wings. So if you have winged aphids in your greenhouse, you probably have a pretty bad infestation. The other thing about these is, as soon as you see a little bit of aphids on a leaf, you need to do something because they reproduce very quickly. Because they don't reproduce with eggs, they produce live young. And so, also as soon as they are born, they are pretty much born pregnant, and the next 1 to 3 days, they're reproducing. So we're talking exponential growth. So you need to get control quickly. If you have some aphids on one leaf, I suggest taking that one leaf off, smashing it, throwing it away. If it's more than one leaf, you can do some spot spraying. Go back here. Spot spraying with maybe some pyrethrum or some oils. But then your predators and your parasites are going to be good. But let me go back here for a second. Also, there's many different types of aphids, many different colors of aphids. Some of them can transmit viruses too. So that's one of the other concerns with having aphids. So some of the signs that you have them, other than just seeing them, is you might see their caskins or those moltings. Their moltings are white in color, and they almost look like a white fly, but they won't really fly. Okay, so they'll be just on the leaf. If you blow on them, they'll not fly, but they'll fall away. But you might see those on the leaf. Also, ants. If you have ants in your greenhouse, the ants are not going to hurt your plants, but they will bring aphids to you and put them on your plants because the aphids are pulling the sap out of your leaves for nitrogen, and they have lots of sugar that they're getting out of the sap that they can't use. So the aphids are going to excrete the sugar water. We call that honeydew. And the ants like to eat that sugar water. And so they actually farm the aphids to get that sugar water. So you want to control your ant population so you don't get aphids coming into your greenhouse. With that honeydew, even if you have ants coming to eat it, that honeydew is going to make a sticky surface on your leaves and on your fruit. And then any fungal spores that are hanging around are going to stick to that and start to germinate from those sugars that are in there. And we get, in particular, we get what's called sooty mold, which is like a brownish black mold on top of that honeydew, and it just makes everything sticky and icky, and it also can decrease photosynthesis because it's covering your leaf. Okay, so back to controls. So you can spot spray with oils. I've not had really good luck with large-scale spraying of oils to control aphids, but beneficials do quite well. So we like to bring in lady beetles, so ladybugs and lacewings, and there's also different parasitic wasps that are particular for aphids. And the Aphidius urvi is one of them, and what it does is it stings the aphid to sort of paralyze it, and it injects its egg into the aphid. Then the egg creates a larvae inside the aphid and eats it alive. And then it desiccates that aphid to make a shell, or what we call a mummy. And then it makes a round hole, and then the good guy, the good parasitic wasp, comes out. So if you happen to see these shells within your aphids, that's a good thing. That means you have some good parasitic wasps there. And you may get some of those naturally, and a lot of times naturally they don't give you enough control, but then that's when you might want to bring extras in to help you out. Now, if you do have to go to chemical controls, these are some of the products that we use for a quicker knockdown, because if you bring in the parasitic wasps and the lady beetles, it's going to take a little while to get control. If you need a quick knockdown, you can use pyrethrum, which is a chrysanthemum extract. Pyganic is one of the companies. And then some of these chemicals, pymetrozine and flunakamide, excuse me if I don't say those right, but those two are anti-feeds. So they, once the aphid feeds on them, it causes them to not want to eat anymore, and they die. The nice thing about these products is all of them are 0-day harvest restriction. So theoretically, you could spray them and harvest the same day. Now, if you anticipate that you're going to have an aphid problem, which a lot of times we get aphids on bell peppers, if you know in your area this is going to be a problem for you, when they're baby plants, you can use a drench at the roots with imidacloprid. And it's a systemic, so that means you're going to drench it. It's going to come up into the roots through the plant tissue. And so when that aphid feeds on it, it's going to die. The problem with this product is that it is a 21-day harvest restriction. So you can't be reactive with this one. You can't say, oh my gosh, I have aphids and I'm harvesting, I got to use imidacloprid. That's not going to work because you can't harvest for 3 weeks. So you need to put this stuff in early on when they're baby plants before you start to harvest. The thing also about imidacloprid is that this is one of those neonicotinoids that's getting bad rap right now for killing bees off in the environment. We've not seen a lot of problems with this with our bumblebees, okay? We use bumblebees in the greenhouse, so they're a little different than honeybees. We've not seen any problems with our peppers and our cucumbers, drenching them. I have not used them on tomatoes, though, because in that case, it gets into the pollen, and it can make your bees kind of drunk. I've not heard where it really kills them off, but it makes them less effective. So we don't use this for tomatoes, but we have used them for cucumbers and peppers. It does quite well. Okay, now whiteflies. This is your next big pest that you will find. Signs that you have whiteflies. So they're little tiny white things flying around. If you touch your leaves, they'll come out at you. If you look on the underside of your leaves, you may see their nymphs. So they have eggs that are very tiny, which you won't see. But their next stage is called a nymphal stage, and it's these little discs, basically, that are on the bottom of your leaves. And they just sit there and feed and feed and feed, and they molt about 4 times, but they're just feeding and feeding and feeding, and finally a whitefly pops out. These also produce honeydew, but you usually don't see honeydew from whiteflies unless you have a pretty good infestation. And whiteflies can produce fruit damage, like uneven ripening of your fruits if you have a lot of whiteflies. The other difficulty that we've been seeing lately is a lot of the Bemisia type whitefly carries these Gemini viruses. And we got hit in 2011, 2012 with tomato yellow leaf curl virus. So our whiteflies that were out in the community and the farms were carrying this virus. We didn't have insect screen at the time. They came into our greenhouse. They were feeding off of our plants. They transmitted that virus to our plants. And it caused stunting of the leaves and loss of production. So you've got to be really careful. There's another virus that's been happening here in Arizona called Torado virus. And this one, you see this burning on the leaves, and it eventually causes the fruits to get leathery, and you can't sell them. So right now, ever since we got hit with the tomato yellow leaf curl virus, we haven't got hit with Torado, thank goodness. But with tomato yellow leaf curl, we use all resistant varieties from now on, because we know we're going to get some level of whiteflies in the greenhouse, even with insect screening, so we want to protect ourselves. So we have all resistant varieties now. Now, whiteflies do all the same type of damage, piercing, sucking mouth parts. They pull the sap out. They make honeydew. They can cause stunting of growth of the plant. But we are concerned with which type of whitefly, because those Bemisia whitefly carry the worst viruses. So it's hard to tell from the whitefly themselves, because it's hard to see them without them flying away. Okay, but if you look at the nymphs that are stationary on the back of your leaves, then you can tell which type you have. The later nymphal stages, if it's the greenhouse whitefly, they have little hairs on them. And if they're the Bemisia whitefly or silverleaf whitefly, they will be flat and look like a trilobite. And so if they're flat ones without hairs, you know you have the worst type of whitefly. Now, for control, you can still use oils on the nymphs, okay? It's hard to spray anything with these flyers. They fly away, the adult whiteflies. So in order to control your adults, it's good to put sticky traps around to just physically, mechanically trap the adults. But we can use some sprays to target the nymphs, or we can bring in biologicals. So in big commercial greenhouse production, we use parasitic wasps. There are 2 in particular, Encarsia and Eretmotsaurus, that we use. And we purchase cards, these little cards that have a mix of those 2 types in there, because they say the one type prefers greenhouse whitefly, the one type prefers Bemisia. I don't really see that being the case. They both will parasitize whiteflies, and each type of whitefly. But these do the same thing as those parasitic wasps for the aphids. They will inject their egg into the whitefly nymph. That egg becomes a wasp larvae, eats it alive, and a good wasp pops out. Now for chemical control for whiteflies, pyrethrum is pretty good, and then these two chemicals, spiramycin and buprofezin, these are two that, well, actually I've used the spiramycin, not the buprofezin yet, but Oberon and Courier are two of the brands for those. And it's really good because whiteflies can be your nemesis. I mean, you can really have a lot of problems with whiteflies, but you have a lot of chemical control options so that you don't develop resistance using the same thing over and over. So you can mix it up here. One time use pyrethrum, the next time use the spiramycin, and rotate. Okay, thrips is another. This was the one I was talking about where we have quite a bit of a tolerance level for thrips because they don't cause a lot of damage for us for peppers or tomatoes or cucumbers typically. They do have the rasping mouth parts as well as the piercing sucking mouth parts. So they will cause some damage to the leaves. They can cause some damage to the fruits as well. They like to go into the flowers and they can deform your fruit formation. So that can be a concern when you're looking at your profitability. Okay. And what you will see is these necrotic spots with little black dots. That's their frass or their poop that they leave behind. It's hard to see the actual thrips sometimes. They're quite fast. They're very tiny and they're quite fast. Okay, so there's some deformed fruit. There's, again, some biological control, specific predatory mites and predatory bugs that you can use. And spinosad is a good chemical to use for treatment. Tomato bugs. Okay, this is another one you might find on tomatoes in particular. They like to be at the top of the plant with the new growth, and they feed in a circle around your stem, and they will cause a necrotic spot, and then your growing head will break off. And then you have to wait for another growing head to come out, but then they may attack that one. So you really need to get control of these things or they're gonna decrease your production. Then of course, caterpillars. So if you get a moth in the greenhouse, they're gonna lay eggs, you could get some caterpillars. We kind of pick them off sometimes. If we find them small enough, we can use BT as a spray to treat for them. When they get bigger, the BT is not real effective, unfortunately. Fungus gnats and shore flies. These you will see a lot at the bottom of your plants on the blocks because they're grazing on the algae that's forming on your blocks. They're more of a nuisance than anything, but if you do have a root-borne disease like Pythium, it can transmit Pythium from one block to the next. So you do have to be careful in those instances, but most of the time we don't have root-borne diseases, so they're more of a nuisance. You put a sticky trap at the bottom and just try to collect them. Just keeping things clean. You can use BT as a drench in the media to help to kill the larvae. And just a really quick note, this is not an insect or a mite, but powdery mildew, fungal. You're very likely to see this on your cucumbers and your peppers. This white fuzziness on the top, it moves very quickly. So again, you want to be quick to treat this. In tomato, a lot of times you're not going to see the fuzzy type of powdery mildew, but you see this slower type that comes in through the stomates on the underside of the leaf and kind of eats its way out. And this is what it looks like. It's yellowy patches that then become necrotic. It almost looks like a nutrient deficiency, but it's not. This is actually a type of powdery mildew, and you'll see some of this in my greenhouse if you come to my workshop on Thursday. So the big thing is look for powdery mildew resistant varieties. You can use a mix of oil and baking soda to control it, but that's sodium bicarbonate, but you can buy products with potassium bicarbonate. Same thing, mix it with water and you're going to spray those plants at least once a week. And then there are some bacteria you can use, and then if it gets really bad, you can use myclobutanol. Rowley's one of the brands, and that will help to really control it, to do spray the whole greenhouse with it. Okay. That is all.
That was pretty concise and to the point, but a lot of information.
Would you, in terms of like nematodes for root protections and root aphids, I know there's like a change in the industry standard because they found that they can feed on roots. Would you still suggest them specifically, I guess, for root aphids or other soil-borne pests?
So I'm sorry, I didn't hear the end part there.
Would you still suggest them, or would you stay away from using nematodes as a beneficial for root pests?
So with using the beneficial nematodes? Yeah. I've not actually used those. They can be helpful with the pests that have a life stage that will be in your media. So thrips have a pupal stage in the media. Your fungus gnats and your shore flies have a stage in the media. So you could use the beneficial nematodes for those particular pests. It's not going to be helpful for white flies, for aphids, and so forth. What's that? Root aphids. I don't know if they're effective on root aphids. I'd have to look that up. Yeah, we don't see root aphids very often. I didn't cover that one because I don't have a lot of experience with them.
In the back?
Yeah.
If you could go back to the tomato bugs, please. I missed the control slide for just a moment. Could you bring that one back up for us?
Okay. You want one back?
Go one more back. Let's see if I got what I was thinking. Or okay, so you didn't have a slide per se on tomato bug control then for either insecticides or other biological controls.
Okay, so when we started getting these, we used to get these, only a few of them, and then one year we got them pretty bad where they were breaking heads off. What we ended up doing was, we didn't know what to do for beneficials because there's not a lot of information out there on that. What we used was a mix of spinosad, I think I had that in there, right? Spinosad, oh, I didn't put it in there, I'm sorry. It was spinosad, pyrethrum, and neem oil, I think is what we used. And the key with the tomato bugs is they lay their eggs inside the stem, in the tissue. So their eggs are protected. So when you spray, you're getting the nymphs and the adults, hopefully if they don't fly away, the adults have wings. But you need to come in every week for about 3 to 4 weeks to get those emerging eggs that are hatching out. So that's what we did. We sprayed for 3 weeks in a row, once a week, and that mix took care of it pretty well.
Yes. This list of bugs that you've listed here today, all the mites and white flies, etc., would I tend to see these in one specific area in a greenhouse versus another? Say Florida versus Montana versus Baltimore?
Right.
Are there bugs I would see in certain areas, or is it because it's protected culture I'm able to see any of them?
Right. Now, the bugs that I covered are good. Almost any of you, wherever you're located, you're probably going to see some of them. There may be some specific other insects that are specific to your area that I might not have covered, and you probably want to get with your extension agents in that area to see what's common in your area.
Okay.
Are there certain beneficials that are restricted from being imported into certain areas of the country?
Within the United States, these big companies like Copert and Biosystems and some other ones, they carry a pretty full line of different beneficials that are specific to different pests. And so you should be able to get or obtain anything you need if you're in the United States. What's that?
Hawaii.
Oh, Hawaii. Oh, that's a good question. I don't know. That's going to be Hawaii would be a little harder.
Don't grow in Hawaii.
Yeah.
Quick question. When spraying said control sprays like neem oil.
Tuck in there a little more.
Oh, my bad. When spraying like neem oils and other pesticides, does it have an effect on the plant leaf, like spotting or
so
anything?
spraying oils, does it have an effect on the plant leaves? That's a very good question. You have to be careful and you don't want to spray a lot. Now, number one, you don't want to spray in the height of the day when the sun is hitting your leaves, because what happens is the sun biomagnifies on the oil and can burn the leaf. So you want to be spraying in the morning, early enough before that sun's going to hit with the oils on there, or you're going to do it toward the evening as the sun's going down. The other thing is you don't want to spray too much. So oils, technically, you could spray every day if you wanted. But the more you spray, the more you're going to dry out your plant and the more damage you're going to cause. So you don't want to overdo it.
Hi. I know you said that you installed some insect netting in your greenhouses, and you still got some insects penetrated the netting. And I know the thrips. I know they actually sell insect netting where they have like different penetration levels for thrips. My question is there any merit in spraying the insect netting with some kind of a repellent that would prevent insects from coming in?
So more
Is that a
preventative.
practice? Is that done, or has that been researched?
You don't want to just spray unless you have an issue, right? But there are some preventative sprays that you can use, a lot of the biologicals. So there are some products out there like Bacillus subtilis, Serenade is one of the brand names. There are some new products out there from BioWorks called Regalia and Venerate, and those are biological-based products that are more preventative. It's bringing the good guys on to build your army up, so when the bad guys come, they fend them off. So those are good ways to put those in your repertoire and to your preventative treatment. Once a week spray with that kind of stuff, that helps. Also for aphids, like a mix with garlic oil is a good repellent also to keep aphids off. Yeah.
I think we have to cut this
Done
off
for now?
here. Can you pass that later on, have that question, please? Let's thank Stacy for her presentation. And I think the important take-home message there is that not if you get insect pests, but when you get insect pests. So be prepared.